Again, good morning to you. Thanks for joining today's webinar. The topic today is meeting AER expectations, evidence-based network analysis for price reset submissions, which all DNSPs go from their time for 5-year cycle. My name is Yogendra Vashishtha, and I'm based in Melbourne. With me, Dr. Kate Thompson. She's joining from UK, and also Dr. David Mills, who will be facilitating the Q&A section today. I really appreciate both Kate and David joining so late for the webinar, which is a good timing for us here. But thank you both. So today, what we plan to present to you is that I'll be very briefly introducing about the EA technology. Most of you know, coming from DNSP and our industry. Then what we have observed from recent AER's determination or draft determination for Victorian DNSPs, which they have gone into the cycle recently. And then we will present to you some case studies from UK and some from Australia, saying there is a kind of analysis which we have done, and hopefully that can assist DNSPs in actually making their submissions even more robust. So EA technology, I don't think it will be new to most of you, but historically it started in 1966 as UK's Electricity Council Research Centre. And since then it has progressed to products and services, and also in the consulting thing. And it has been acquired by Suma Equity recently. So it is growing actually. So the basic thing is from 1966, and the focus has been on electricity and our transformation in the electricity sector. A couple of products and services which are more of modeling and monitoring, of the network. So there are a couple of products. I'll not go into that these times. But in terms of the consultancy, we can call it net zero, or we can call it future networks, depending on the jurisdiction where it is called. But basically, EA technology working very closely with the partners, especially in the electricity networks. And we have the skill to understand the regulatory environment. We have extensive experience of scenario analysis, which we will present today. And DER or CER integration has been one of the key topics, especially in the last 5-10 years. So we have been working, including working with Australian industry also for DSO thing, and integrating the low carbon technologies or CERs into the network, finding the network strategies to facilitate that transformation to happen. So we have been working in this area. Now, regulators' expectations. So what we observed is that in the recent draft determination for Victorian DNSPs, the AER has made some observations, which are, just to give you some feel, they're saying the demand forecasts are weak and not transparent. The spend uplifts are not justified, and supporting evidence is not deep enough. So our takeaway from that is that AER is basically asking for evidence-based demand buildups and a transparent methodology. Those who know that, we all used to do the risk analysis and risk models, and the CBRM came and became easy for the regulator to understand that yes, there is a standard methodology which is transparent. And I think AER must be looking for something like that there is a methodology which they can actually verify, validate, and test it, and which is a standard. So for demand forecast, and demand forecast is becoming more and more complex, and you know why. It is not an easy science. It was never an easy science earlier, but now in the current scenario where there is no boundaries between generation and load, it is becoming even more challenging. Business case supported by the robust analysis, that's their expectation is, And definitely they're looking for more of a quantitative evidence to justify the step up expenditures, which we all need as DNSPs, but we have to just, put the case and compelling reasons why this has to be done. Some of the recent developments in Australia, as you know, that we always used to have value of customer reliability, but now there is a value of network resilience. So that means, there is a focus. AER is saying that to deal with the extreme weather conditions and remoteness in Australia, there is a value they have set for network resilience. But networks have to come up with that, proposal and justify that this is the, in the long-term interest of the customer. Ultimately, that is the prudency test for regulator, and saying whatever you and me are doing, it is in the long-term benefit of the customer. Now, we have seen the enhanced system planning that ISP is integrating or to integrate the distribution system considerations. AER has also come up with the policy-led sandboxing and energy innovation toolkit. So basically, they're saying they can, relax some of the regulatory rules if there is a good reason to do that, and to do a trial or recently NAM review has done, and it also has one element for CER, DER reforms. And AEMC is currently, doing the electricity price reform programs, which are also designed to support the CER integration. So there's a lot happening in this area. Now, I'll actually request my colleague from UK, Kate, to take over from here and present some case studies from there.
Good morning, everybody. As Yogendra said, my name is Kate. I sit in the consultancy team in the UK, where I mainly work on network capacity related forecasting projects. And for today, I am going to focus on load related forecasting and reliability assessments. So let's start with load related investment. EA technology have been part of load-related investment forecasting in the UK since 2015, pre-2015 and ED1 price periods, when Ofgem developed a smart grid forum project that was a collaborative project between UK DNOs to develop a system of modelling that could forecast better and standardize load-related investment. And from that project grew the transform model. The transform model is a parametric network forecasting tool. It uses network parameters that are grouped into typical archetypes of specific network qualities, uptake scenarios for different distributed energy resources and low carbon technologies, and a series of network-based investment solutions to increase capacity. It puts these through a modeling engine and then produces at the other end a investment profile. The idea of building the transform model was to improve the standardization and the evidence base for network investment decisions that were occurring within the UK network operators markets as they were building their price period plans. And transform is used now extensively in a multitude of different projects within the UK. I'm going to talk about two that are specifically on load-related forecasting now. Yogendra, can you do the next slide, please? So the first project is a DNO-specific project. DNOs in the UK are seeing more and more scrutiny on developing their price period plans and how they are justifying the volumes of investment, capital and operational expenditure that they're going to need during a given price period block. They know that within the UK, we're seeing a very large shift towards electrification of heat and transport, and large volumes of generation are joining on the distribution network. And this is resulting in large volumes of expenditure that are required, and they need to justify that need to reinforce their network with the regulator. Whilst the regulator, on the converse of that, are putting more and more pressure on the network operators to justify their expenditure in these areas. So they use Transform to develop an independent and highly adaptive but standardized format for producing some of these investment numbers. In this project, we looked at the 3 different future energy scenarios for this distribution network operator and calculated the reinforcement costs that would be needed over each of the different voltage levels of their network for the 3 scenarios. And by doing this, we could allow the network operators to develop a broad overview of what the different scenarios would look like in terms of expenditure between now and 2050. We could also consider changes within the scenarios that were driving differences in investment. For example, during this project, it was made very clear that assumptions around battery energy storage within UK modelling was causing a drive towards higher investment requirements. And that actually shaped part of the response to business plans and additional sensitivities on battery behaviour and how this may impact the cost and expenditure of network operators, and how this is a big grey area in the UK for how they're going to plan their network moving into the next price period, as well as distribution network operator specific projects. Transform has also been used by government entities within the UK. So it isn't just a network operator based tool, and it is trusted by different aspects of the industry. Within this project, we looked at some national forecasting for the UK government to ensure that their policies and their directions would achieve net zero, and also how large of an expenditure achieving that net zero target might result in. We also, during this model, assessed the volume of capacity that the distribution networks would need to reach those net zero targets. Using a consortium of UK distribution network operators, a singular view of the network was modelled within Transform, and then 14 different scenarios varying volumes of heat electrification, industrial and commercial electrification, weather events and different weather forecasting and cold weather event scenarios, and also singular large demand sites like data centres were considered, and a range of different expenditures were extracted from that modelling. We determined that by 2050, peak demand was due to that, and the maximum scenarios could almost triple, and would more than double in some of the lower base scenarios, and that this would result in an expenditure for our core scenarios of up to £50 billion within the UK. But when we looked at extreme weather events, this could go up to £76 billion, which, when compared to other investment cycles that had been assessed, was far greater than historical budgets, and outlined how changing policies within the UK and different considerations on LCT uptakes had a vast impact on how expenditure was going to happen on our distribution networks, and things that needed to be considered to reach our net zero targets. So I talked a little bit about our Transform model. And as I said, Transform was developed ahead of ED1 and was developed to be a fast, scalable, adaptive tool that allowed quantification of reinforcement strategies. It was based on a network that had minimal data at the LV level, and was designed to be really adaptable to any network, regardless of whether you had large volumes of data and large volumes of information or you didn't. Moving into ED2, as networks within the UK started to increase in digitalization and volumes of connectivity and network-based data, EA Technology developed what we called the Network Investment Forecasting Tool, or NIFT. And this was designed to take low voltage connectivity data and combine this with load flow modeling to forecast how low carbon technologies on the network would result in constraints at a feeder by feeder level, and how different reinforcement solutions could be deployed in order to alleviate these constraints. Moving into ED3, this load-based forecasting has then been developed into a more comprehensive tool, which we call VisNet Forecast. And this again uses connectivity models and load profiles to determine what breaks when scenarios on LV networks at a feeder by feeder level. It's designed to be detailed and standardized, and utilizes a range of different can analyze a range of different scenario intakes to assess how load-related expenditure might be occurring at a much more granular, detailed level than what Transform would be able to do. But that comes with the necessity of needing a detailed volume of data, of connectivity models within your network. And what's come from our input into network forecasting throughout the UK is that different DNOs will be at different points within the position of this cycle between Transform and VisNet Forecast. But at some point in that journey, EA Technology have load-related forecasting tool or experience to help on that journey and help develop that evidence that's needed. So just before I finish on the load-related expenditure portion of what I'm going to talk about, I just wanted to highlight again VisNet Forecast. It's very new, but it does offer this robust, wider scenario integration to unlock insights and evidence at the LV level for investment-based planning. So alongside load-related expenditure assessments, there is a growth in the UK from the regulator of understanding better how reliability improvements are being developed through business plans, and particularly how the networks are strategically reducing the frequency and duration of interruptions on their network. EA Technology also are helping DNOs within the UK to strategically plan and manage on their HV network where to add automation, strategically sectionalize off the network. And we do this using a tool called Target. So Target is a Monte Carlo-based simulation tool that utilizes SQL-based tables from network connectivity data in order to assess the rate of failures upon HV connected networks. And from this, it can determine what distribution substations are likely to see the most customer interruptions and the most customer minutes lost based on predictable faults of assets such as lines and cables on the HV circuit. It can then identify areas where poor performance is expected on the network and you're going to see high failure rates. And from this, we can then add in automation of switching or different sectionalization pathways in order to assess and improve the rate at which customers are experiencing interruptions. Target can also assess weather-based scenarios to understand how weather impacts might impact the HV network moving forward into situations where climate change becomes an impact. So within these assessments, the Target model takes an extraction of HV networks from a given network operator and inputs these into the target modeling, where a large series of years are simulated of network operation. And through this and historical fault data, we can then determine areas of the network that are likely to see high failure rates and therefore lots of interruptions and minutes lost for customers on the network. Once these failure points are identified, the customer interruptions and the minutes lost can be quantified at a substation level, and metrics can be pulled out to rank these different failure modes. From that, we can then use strategic placement of automation or sectionalize the network with open points in order to reduce these customer minutes lost and customer interruptions. And what this allows the network operators to do is, instead of making broad assumptions on every 100 customers where they will add automation, they can make targeted investments to specific sites where they're more likely to see occurrences of failures and strategically secure resilience within their network, which will reduce the impact that they have on customers moving forward throughout the price period and ensure that they're making the best investments from a reliability perspective. And that's me done. So I'll hand back to Yogendra, who will talk about some of the Australia-based case studies.
So I'm actually going to present to you one case study from Australia. So this was from Test Networks. And the question was that, what is the best LV management strategy at this point in time, which Test Networks can consider. So as Kate said, everyone is at different level in the journey, like what we have seen is from ED1, ED2, ED3. Every DNSP will have a different, they will be at a different point in time, and they're progressing towards that in terms of the LV visibility and connectivity model. So depending on what is available, we can actually apply. So in this case, we applied the transfer model to actually make a representative LV network. And then it was decided, it was actually very quickly when we did the hosting capacity analysis, we realized that for test networks, unlike SAPN or something, their immediate issue is not solar PV, it is EVs. And then we consider the EVs, the strategies of time of use tariff and demand side management, to manage the network. And both these strategies were actually considered and analyzed. So I'm going to present to you what exactly we did. So, transfer model, it considered, 20 feeders, just representative types, and then actually tried to replicate the network, demand and feeder demand and number of feeders and all that kind of thing. So it is actually constructed that it is a representative network for test networks. And then the next challenge was, what is if EV is going to be a problem, what is going to be the EV profile, which is the hardest thing. So because see, whatever we are getting now is early adopters. So what we don't know is there are a lot of uncertainties, and then also comparing the overseas profile to the local profile. Like EA Technology had done a lot of work in the Electric Nation trial and the subsequent trial. So for this study, we have taken Electric Nation profiles, but we have then customized it or localized it to the Tasmanian thing, the kind of customer behavior, the maximum travel we can expect, and total energy then in that profile for Tasmanian, the EV owner, and that we have. So what we have done is we have taken the Electric Nation profile and actually made it, adjusted it to the Tasmanian thing, whatever we knew at that point in time. Now, there are still a lot of challenges there are a lot of uncertainties in terms of the, behavior of the EV owners in terms of when there will be mass population, not just early adopters. So this is still an area of evolving. But here what you will see is actually there are two things which we are taking a standard high and low. High and low means there are the feeders which has more number of customers and more EVs, and there are regional feeders which are very less customers and less number of things. So we basically taken two distinct profiles, and then we have applied the time of use tariff and seeing how this profile is likely to change. Obviously, when we use time of use tariff, the evening charging will shift to the morning, and that's where we are seeing these effects. But this is still an open question and on an evolving area of using the EV profile, which is suitable to Australia, and even different state and different kind of incentives which people are having and policies which are coming. And as a net result, what will actually be the EV profile? Now, time of use tariff, as you know, that we actually just tried and saying, okay, baseline, which is like 35% people opt in, and then going to 65% and 100% opt-ins for time of use tariff. And I mean, so we are saying what will be the effect, and as you would expect that when we go to 100%, it will create very high morning peaks and will require further network investments. So there is pros and cons for that. Then we also did some sensitivity analysis saying, all right, when do we act? Do we act at circuit intervention threshold limit as 80%, 90%, 100%? Yes, the ideal thing is we should act as 100% just in time, more cost effective, but then it may be not possible to actually have those solutions ready. So if we act before that, there will be a little bit more cost, but then we'll have more time to manage and to have the uptake, control the uptake rate. So this is the kind of analysis, and this is done for, I'm just presenting for one scenario, but that time, whatever the ISP scenarios are for step change and hydrogen export, we did for all the scenarios. So just representing one example here. Similarly, we analyze demand side management, another solution. And we actually took just saying that, okay, what we start with 50% and 75%, then 100% participation. And then we just say, okay, 10 cents per kilowatt hour to 20 and 30 cents like that. You will notice here that, it doesn't change much with the low, medium, high. And the reason for that, I can explain to you in this particular case, is that whatever constraints we saw, they were actually fairly met by 50% participation anyway. So then further it was not doing much, but that may not be the case for everyone. Now, for the DSM also, we did a kind of scenario build-up and saying, all right, this is just an example for a feeder, and saying what will happen from the later on if we use the DSM. We will be actually, curtailing some kind of EV charging. But when is the point when this curtailment will become intolerable, and then we have to go for the network solution anyway? So we were trying to find out up to what. So in this case, the feeder was like saying that 25 kilowatt is the limit for the evening peak. And so we are seeing that, in 2047, probably the network solution will be required. But in 2044 to 46, a DSM has to be triggered. And before that, it may not be required for this particular feeder. So this kind of analysis for the representative feeders we did. Then we did the sensitivity analysis, as I said, for varying the cost, but we have not taken the cost of enabling cost at the time. And we have also not considered the other benefits which DSM will bring, like, for example, even for the resilience and network restorations. So we have not considered all the benefits which are possible from DSM. We have just taken this case study for comparing the LV management strategies in this case. The key findings were that we should aim for 65% TOU implementation. That will work. 50% DSM is enough. And then I think further studies are required when we get most confirmation about the profiles, and also when we use both TOU and DSM together, what will be the result? That we have, this was not done in this study, and it will be interesting to know when we offer time of use tariff, and we also offer the incentives for demand side participation, and when we do together, how things will shape up. So that is still area to study further. Then we finally, said, okay, all right, what is the network investment savings under different? So as you said that time, net zero scenario, the step change scenario, slow change, and hydrogen export. So a step change was more favored one. So basically we are saying, if we have TOU for medium, high, and low, what are the percentage savings? And if we have DSM, low, medium, and high, what are the savings? So under each scenario. So this is the kind of analysis we did at that point in time for test networks. In summary, what we are saying is that, we're not saying that EA technology can write your regulatory reset summation or can actually solve all the problems. But what we are saying is that the kind of analysis we have done since ED1, ED2, ED3 there, or we have been doing for SA Power Network or test networks and other networks here, and also, working in the area of both modeling, monitoring, and also, reliability, resilience, power quality, working very closely with the network, I think we can definitely offer some value in making your analysis more compelling, more evidence-based, more transparent, and that's where we are saying we are happy to talk to you. The purpose of the webinar is that we can talk to you and discuss what is your context, what is your pain points, where you want us to actually focus. The EA technology can actually definitely assist with their experience, global experience, and local knowledge of the networks, and the regulatory cycles and the transformation happening here. So that was the purpose for today's webinar. Now, the big one is coming. The ENA conference is coming. So, we'll see you there. Definitely, Kate is there, and Neil Davies is there. Simon is there. Marcus Person is coming from UK. I think the whole team is here. So we will be happy to discuss. I'm missing because I'm overseas that time, but normally I also attend the ENA conference because that's a really good one this time. But Kate is there, you will be there, and other people are coming from Australia and UK. So the whole team is there. We have got a stand there. So we can actually progress the discussion there. Kate is also presenting, and so the Mark is presenting there in the conference. So happy for you to join those presentations from EA Technology at the ENA conference. And we are almost there. So look, thank you very much for joining today's webinar, and we love to hear from you. I'm based in Melbourne, happy to, take your call, discuss what I know, and involve people from, our global offices as required. But happy to discuss what your exact needs are at this point in time and for the next regulatory cycle. So it is like what expenditures you want to do step up. Is it that the resilience? Are you going to the sandboxing kind of thing you want to try in the next research cycle? So what is that? How to formulate the case for that regulatory sandboxing, or how to come up with strong justification for your resilience thing, which depending on the area where we have bushfires or we have storms, and where we want to focus on, and in general, your network connectivity, or the data, we have the strategy where we want to take even data strategy, where we want to take it and why. So there is a justification that what should be the pathway for a DNSP to develop the digital infrastructure, and why. If there is a clear direction, if they want to go to dynamic operating envelope, we want to go to the flexible export, so when, which year, and what is that journey from now to that year. So how to say that, how to justify that, how to build up those cases. That's where we want to come and help you whenever. So please do consider us, and thanks again for joining today. Thank you, everyone.